Hello. Hello.
Yes, sir. Good morning.
गुड मॉर्निंग। आपकी जो क्विज है वो पोस्टपोन्ड हो गई है, तो ये 11 तारीख को होगी, ठीक है, 11 नवंबर को।
ओके सर।
ठीक है, मैं एक मैसेज डाल दूंगा डेट के लिए कि किस तारीख को होना है, और आज आप लोग कनेक्ट हो जाइए। तो आज क्लास अभी ये हो जाएगी दोनों सेक्शन की कंबाइन, और तो कनेक्ट हो जाइए फटाफट। ओके, तो आप लोग एक काम करिएगा, सभी लोग अपने अपने क्लास में जो आपका ग्रुप है वो इसमें जो है आप लोग अपने चैट बॉक्स में अपने अपने क्लास में जितने भी बच्चे हैं सभी लोग अटेंडेंस चैट बॉक्स में विथ रोल नंबर, नेम और क्लास का नेम डालते हुए अपना जो है अटेंडेंस मार्क कर दीजिएगा, ठीक है। हेलो, इज इट क्लियर?
यस
मेरी
सर।
आवाज आ रही है? सभी
यस
सभी लोग
सर।
चैट बॉक्स में अपनी अटेंडेंस मार्क कर
ओके सर।
दीजिएगा, अपने रिगार्डिंग जो भी आपका क्लास ग्रुप है, नेम एंड रोल नंबर, इतनी चीजें रहनी चाहिए। 7172 तो है 7172, EC 7172, 7374 है तो EC 7374, अंडर स्कोर योर नेम एंड अंडर स्कोर योर रोल नंबर, ठीक है। इज इट क्लियर? ओके, सो नाउ स्टार्ट करते हैं हम लोग। मेरी वॉइस क्लियर आ रही है सभी को?
यस सर, वेरी क्लियर।
ओके ओके, सो जहाँ हम लोगों ने पढ़ा था उसी के आगे स्टार्ट करते हैं। It is visible to all of you. Hello. Hello. This is visible to all of you. Controlled access protocol.
Yes.
Okay.
यस सर।
So we will discuss now. हमने आपको बताया था कि जो हमारा मल्टीपल एक्सेस स्कीम है वो 3 कैटेगरी में डिवाइडेड है, ठीक है। इसमें आपका सबसे पहले आपका आता था रैंडम एक्सेस प्रोटोकॉल, फिर कंट्रोल्ड एक्सेस प्रोटोकॉल, देन चैनलाइजेशन एक्सेस प्रोटोकॉल। क्लियर? क्लियर। तो जो हम लोगों ने अभी रैंडम एक्सेस प्रोटोकॉल पढ़ा था उसमें हम लोगों ने पढ़ा स्लॉटेड एलोहा, प्योर एलोहा। क्लियर। उसके बाद हम लोगों ने उसमें CSMA पढ़ा। CSMA में भी हमारे पास दो थे, CSMA CD एंड CSMA CA। क्लियर। तो CSMA CA अभी हम लोग फिर डिस्कस कर लेंगे, पहले कंट्रोल्ड एक्सेस प्रोटोकॉल देख लेते हैं। तो दिस इज द अनदर कैटेगरी ऑफ द मल्टीपल एक्सेस स्कीम, दैट इज कंट्रोल्ड एक्सेस प्रोटोकॉल। और इसमें और हमारे रैंडम एक्सेस प्रोटोकॉल में ये डिफरेंस है कि जो रैंडम एक्सेस प्रोटोकॉल स्कीम है उसमें जो डेटा है या जो हमारा फ्रेम है वो रैंडमली एक्सेस होता है, ठीक है, चैनल के थ्रू। बट इन कंट्रोल्ड एक्सेस प्रोटोकॉल द प्रोसेसिंग इज व्हाट with the not randomly, but it is what it is in scheduled way, clear, it is in a controlled way, ठीक है। तो इसमें क्या होता है, द स्टेशन सीक्स इंफॉर्मेशन फ्रॉम वन अनदर टू फाइंड विच स्टेशन हैज द राइट टू सेंड, ठीक है। तो जो भी हमारे पास स्टेशंस हैं या जो भी नोड्स हैं वो क्या करते हैं, वन एंड मतलब जो भी नेबरिंग नोड्स होते हैं उनसे इंफॉर्मेशन कलेक्ट करते हैं कि हमारे पास कौन से स्टेशन को राइट है सेंड करने की, ठीक है, विच स्टेशन हैज द राइट टू सेंड द डेटा। तो सबसे पहले ये हमारा जो है क्लियर होता है, सारे नोड्स एक दूसरे से क्लियर करते हैं। देन इट अलाउज ओनली वन नोड टू सेंड एट ए टाइम। यस, ये एक ही नोड को अलाउ करेगा डेटा सेंड करने के लिए, ठीक है ना। इट अलाउज ओनली वन नोड टू सेंड a डेटा एट ए टाइम। My voice is clear to all of you, no?
Yes, sir.
Okay. So there are exactly three control access methods are there: reservation, polling, and token passing. This control access protocol. So reservation means you all know, as in general reservation means जैसे हम as we all travel from one place to another through any medium, something like train or plane or whatever is that, clear? So we need to make their seat reserved, clear? हम सबसे पहले क्या करते हैं, सीट अपनी रिजर्वेशन कराते हैं जिससे हमें वो सीट हमारी अवेलेबल रहे, क्लियर? सो इन दिस रिगार्ड, इन दिस पर्टिकुलर मेथड, a station need to make a reservation before sending data, clear? Means you need to allocate yourself a particular time slot or duration where you can send the data, and at that particular time slot no other node can access the data, clear? So that's why the reservation is important. So the timeline has two kinds of periods exactly: reservation interval for fixed time length and the data transmission period of variable frame, clear? If there are m stations, okay, so if there are m stations, the reservation interval is divided into m slots and each station has one slot, clear? It means suppose we are having m stations, so reservation interval is divided into m different time slots, clear? And each station has one slot, means suppose we have M1, M2, M3, M4 slots are there, and so we will allocate each station to different times. The first station will allocate M1 slot to send the data, second station allocate the M2 time slot to send the data, clear? And something like that, clear? So and suppose if station 1 has a frame to send, it transmit 1 bit during the particular slot. No other station is allowed to transmit during this particular. Means if the station has to send the data for a particular slot, so it can send the data, but no other node will occupy that slot at that time, yeah, for sending purpose. In general, if ith station may announce that it has frame to send, then it is just inserting a bit, one bit into the IS slot when all n slots have been checked, clear? And if each station knows that which station wish to transmit, clear? It means we can say the station which has reserved their slot so they can transmit their frame in that particular order, clear? After data transmission period has been over, after data transmission has been over, then next reservation interval will begin. Yeah. So since everyone agrees on who goes next, so there will never be any type of collisions. Means हर किसी को हर सारे नोड्स को इन नेबरिंग नोड्स के बारे में अगर पता है कि उस टाइम पे कौन डेटा एक्सेस कर रहा है चैनल के थ्रू, so never collision will happen, clear? So जैसा कि रैंडम एक्सेस में क्या हो रहा था कि रैंडमली पर्टिकुलर किसी टाइम स्टैंड के बाद कोई भी नोड जो है डेटा को चैनल में थ्रो कर रहा था, तो उससे क्या हो रहा था कि कोलिजन के चांसेस अकर हो रहे थे क्योंकि किसी को कोई टाइम स्लॉट अलॉट नहीं है, ठीक है ना? बट इन दिस वे you will be allowed a particular time slot, so the access will be very much correct. So there is a figure for this particular method. You can see in this reservation scheme, you can see the packets 1, 3 and 4 get successfully transferred because they are transferred in their particular time slot and no collision occurs. Clear? You can see this with the frame. Is the packet transmission diagram. You can see there is a reservation frame 1, 2, 3, 4, 5. Clear? With the allocation 0, 0, 0. So if we allot first frame in particular data station 1, clear, and the second frame in data station 2, third frame in data station 3, fourth frame 4, and fifth one is in data station 5. Clear? So you can see that the first frame in the right side, the first frame accessing data station first, the third frame is accessing data station 3, and the fourth frame is accessing data station 4. Clear? So we can say first, third, and fourth data frames are transmitting successfully without any collisions. Now the next method is the polling method. Here, now the next method is the polling method. In this polling method, exactly, it is similar to the roll call performed in a class. It means just like the teacher, a controller sends a message to each node in turn. It means there is a controller and there is a secondary receiver. Clear? You can say. So the primary controller access the channel all the time. Clear? And it controls the frame or packet instance. It controls the frame or packet regularly. Clear? But the secondary node or station cannot control the packet. Clear? Means the primary controller always control the channel. Clear? So the message sent by the controller contains the address of the node being selected for granting access. It means जो भी मैसेज कंट्रोलर सेंड करेगा उसका एड्रेस होना चाहिए. जैसे मान लीजिए सेकेंडरी में हमारे पास वी हैव 2 और 3 नोड्स. क्लियर? सो ये मान लीजिए वो तो जो भी पैकेट या मैसेज भेजेगा प्राइमरी कंट्रोलर वो सारे नोड्स के पास सेकेंडरी के पास जाएगा. ठीक है? बट एट दैट टाइम all the secondary nodes will access that particular packet. Clear? And they will check that if the address is relevant to that or not. Clear? Means all secondary nodes will access that particular packet from the primary station and check that all the address is relevant to them or not. Clear? If the address is not relevant to them for that particular packet, they will send the negative acknowledgement. Please, you can see they will send the negative acknowledgement. Or if they don't have another one is if they don't have any kind of data to send. Means suppose the address is matched at the secondary side, but they don't have the data to send to the primary controller, so they also send the negative acknowledgement. And if the address is not matched, then they can send the negative acknowledgement. See, this primary station, you can see the diagram. You can see the diagram. Primary station polls to the secondary side. Clear? And if the address match to the secondary sides, means a primary controller want the data from the secondary side if there is a data available on the particular node address. Clear? And if the data is not available, the secondary node will send the negative acknowledgement to the primary side. Clear? So now the second case is what? Suppose we have the data on the secondary side, means the primary station or node polls to the secondary side and the secondary side have the data to send to the primary side. So then it will send the data. If it has the data, it will send the data to the primary side, and then the primary controller will send the acknowledgement. It means it will say that I have received the positive data, whatever you have sent. So it will just acknowledge to the secondary side, to that particular node, that the data is received. Clear? So You can see from the diagram. The diagram is visible to all of you. This diagram is
Yes,
visible to all of you.
yes,
Yes, sir.
Okay.
NAC diagram.
Yeah, sure. Now we come to next. If you find the efficiency here, now if you find the efficiency, then you can calculate the efficiency. The efficiency of the polling method is what? It is equal to what? TT upon TT plus TPOL. This TPOL is the time for polling from the controller to the secondary side. TT is the time required for transmission of data. Means suppose the controller polls to the secondary node at a particular toll time, that is TPOL, and then if the secondary node have the data to send to the primary side, then it has the transmission time, that is TT. Clear? So the efficiency will be what? Transmission time upon transmission time plus hold time. This is the efficiency of this particular method. Clear? Now the last one is token passing. In this token passing method, clear, of the reservation, in this token passing method of the controlled access protocol, this is the third one of the controlled access protocol, that is token passing. In this token passing scheme, as you all have been aware from this particular token bus system, I think. Have you heard about token bus system?
Yes, जब भी जिस चीज को एक्सेस करना होता है उसको एक पर्टिकुलर टोकन दे देते हैं, जब उसका वो वो वाली बस एक्सेस हो जाती है.
Okay. So token bus is a type of line process. Clear? Line type system. Means we have the arrangement of nodes in a particular line. Clear? But and we have several stations, so the token will be passes to all stations at a time. Suppose which station have the data to send, then they can send. Clear? Similarly, this token passing scheme, generally we have a ring system. Clear? We have a ring system, and access of station is governed by the token. Clear? The access of the stations is governed by the token. So it may be the bit pattern or small messages. Clear? It may be the bit pattern is 1001 form, that is the bit pattern, or type of small message. Clear? So a token will be circulated from one station to next station in a predefined manner. Clear? Means the token will pass into the ring from one node to all other nodes. So suppose any node have the data to send into the system. Yeah. So after receiving the token, it will be allotted a particular time slot, and they will know that they have been allocated a time slot, so they can send their data. Clear? In that particular time slot. So and in token ring, the token is processed from one station to another adjacent station in the ring, where an increase of token bus, each station uses the bus to send and the token to the next station in some predefined order. In both cases, the token represents permission to send. Here, it means suppose if a station has a frame queued here from transmission, when it receives the token, it can send that frame before it passes the token to the next frame. Means अगर एक स्टेशन के पास फ्रेम है सेंड करने के लिए और वो टोकन रिसीव करता है, तो वो टोकन नेक्स्ट स्टेशन को तभी पास करेगा जब वो उस फ्रेम को जो है उसमें चैनल में एक्सेस करा देगा. क्लियर? मतलब अगर आपके पास टोकन है, आपको टोकन रिसीव हुआ, तो इट मींस यू नीड टू सेंड योर पर्टिकुलर फ्रेम इफ यू हैव द फ्रेम, अदरवाइज यू कैन पास द टोकन टू द nearby node, yeah, nearby station. If it has no queued frame, then it passes the token simply. Clear? मान लीजिए अगर चैनल आपका बिजी है, हो सकता है आपके पहले वाले नोड ने एक फ्रेम को एक्सेस कराया चैनल में टोकन रिसीव होने के पास, ठीक है, जब वो पास हो गया तब वो टोकन आप सेकंड वाले को पास होगा, क्लियर, और वो भी एक्सेस करेगा। अगर चैनल बिजी है तो इट विल नॉट सेंड द डेटा एट दैट टाइम, इफ द चैनल इज फ्री इट विल सेंड द data by receiving the token. Yeah. So
Yes, sir.
after sending a frame, each station must wait for all n stations. Clear? So including itself to send the token to their neighbors and the other n-1 station to send the frame. Clear? If they have one. There exists problem like duplication of token or token is lost or insertion of new station. So most of the time it exists problem like duplication of the token, means two stations may have received the token at the same time. Yes, same token is received here, or the token is lost. So insertion of a new station or removal of a station which needs to be tackled for correct and reliable operation of this scheme. So this is the diagram. You can see all the stations are arranged in a circular fashion. So token are passing from one station to another station in something like this, yeah, in a ring fashion. So if we talk about the performance of token ring can be conducted by two parameters. First one is delay, which is a measure of time between when a packet is ready and when it is delivered. So the average time delay required to send a token to the next station is equal to A by N. So efficiency or throughput, which is a measure of successful traffic, so it can be calculated by S is equal to S or beta is equal to 1 upon 1 plus A by N, where A is less than 1. Okay, so in this way, if you further solve this, so S is equal to 1 upon A. If you take A as a common, so A 1 plus 1 by N for A is greater than 1, where N is the number of station and A is equal to TP by TT. TP by TT means TP is the propagation delay and TT is the transmission delay. Clear? Transmission duration, time, yeah, transmission delay. So in this fashion, you can find the efficiency of token-based system. Clear? Is it clear to all of you? Hello? This token system is clear to all of you? Hello? Hello?
Yes, sir.
So the system is over. Clear. So now we move to next system. That I am sharing again. So all of you please mark your attendance in the chat box. All of you, please mark your attendance in the chat box. मेरी आवाज, सभी लोग अपनी अटेंडेंस मार्क कर दीजिए. हेलो.
ये सर मार कर दो.
मार्क कर दिया.
हाँ, जो भी लोग हैं अपनी अटेंडेंस मार्क कर दीजिएगा, ठीक है ना. कोई
ठीक है
ऐसा ना हो जो अटेंडेंस ना मार्क करने या एब्सेंट हो जाएंगे. सभी लोग अपनी अटेंडेंस मार्क कर दीजिएगा प्लीज. Just wait, I am sharing the document. So the next method is the channelization protocol. Clear? The next method is the channelization protocol. EDMA and CDMA. Clear? So this particular scheme of the channelization protocol वेट करिएगा, मैं शेयर कर रहा हूँ फाइल एक्सेस. वेट करिए जरा, मैं फाइल शेयर कर रहा हूँ, जरा वेट करिएगा आप लोग. Hello. So this is the another method, that is controlled channelization protocol. This channelization protocol scheme we have FDMA, TDMA, and CDMA. Clear? FDMA, TDMA, and CDMA. So we have just covered the control access protocol, and now we move toward channelization protocol. Initially, we have discussed random access protocol with the Aloha CSMA scheme. Clear? I'm just revising this one again. In this random access scheme, we have discussed Aloha, slotted Aloha, and pure Aloha, where random access scheme is followed, and we have just calculated the efficiency of both of them, slotted Aloha as pure Aloha. Then we move towards CSMA scheme. So in this particular CSMA scheme, you all can see that all the stations, before sending their frames into the channel, they sense the channel, that the channel is idle or busy. After that, they send the packet into the channel. Clear? And in this particular case of CSMA CD, means if the channel gets still if the packets or frames are still get collide into the channel, then the collision will be detected, and how the that detected packet collided packet will be allocated into the channel. This is the collision detection scheme of CSMA. So collision avoidance scheme, we will just avoid that particular collision with some different techniques. Clear? So these all have been these all we have discussed, and now we will discuss about the CSMA. We have already discussed, that is non P persistent, I persistent, and non persistent method. Clear? So, and CSMA CD, we have discussed that the transmission time for each station. Clear? So this all have been discussed. Now this is the flow diagram for CSMA CD process. Clear? This is the flow diagram. We have a start of frame at k is equal to 0, and then apply one of the persistent method, that is I persistent, non-persistent, or P persistent method to send their data. Clear? So by applying these protocol method, that is I persistent, non-persistent, or P persistent method, clear, the transmission done or collision detected. If the packet is sent for particular persistent method, as we have already discussed that in CSMA, three methods are follows, that is I persistent, P persistent, and non-persistent method before transmission of data. So in P persistent, we have discussed that if the data is accessing by any kind of node, and if it finds the channel idle, then it sends the data immediately without waiting time. Clear? And in non-persistent method, it just sends that channel. If the channel is idle, then it sends the data, and if the channel is busy, it just wait for a random duration of time before sending the data into the channel. Clear? So all the station at the same time randomly waits before sending their packet or frame. So most of the time collision occur in non-persistent method. Clear? And in case of I persistent method, uh, we have discussed that if there is a non-idle situation into the channel, then it just sends or it just allocate a particular time slot before sending the data. Here, this is called I persistent method. So it just apply the any kind of method and then process the data to the next step. And if all the one of the persistent method category is following, then it sends the data and the transmission done if the collision not detected. If the collision detected, then it will back to something like this, means collision is detected, so no successful transmission is there. Clear? And if the collision is non-detected, then it will send the data clear and successfully. And if the collision is detected, then it sends a jamming signal. Clear? And just increase the value of k, that is k is equal to 0 plus 1, that is the next step. Clear? In the next stage, it will add the jamming signal into the system, and then k will be, if k is greater than k max is maximum 15. Clear? If k is greater than k max, then it will abort the packet, means k max is what the maximum iteration it can apply. Clear? So maximum it can apply up to 15 times. Clear? Means it can send the packet maximum 15 times. If the packet gets distorted or something, any other problem arises into the channel. Clear? So suppose we have k is equal to k plus 1. It means we have k is equal to 0 plus 1 means that is 1. So this is less than k max. Clear? So what will happen? You can see this condition here. Means if k is not greater than k max, then this above condition will arise. It means choose a random number r between 0 to 2 ki power k minus 1, and it will just wait for the back of time. Clear? So this is the another scheme. And now there is a carrier sense multiple access with collision avoidance. So in this collision avoidance, we are discussing that if the collision is detected, means the packet gets disturbed. Clear? So into the channel. So how we can avoid that collision? So we are having three schemes to avoid the collision in this collision avoidance scheme. The first one is interframe space, means we just provide the interframe space into the channel. Clear? Before for each station, there will be a interframe space before transmitting to the next time slot. Clear? So if the stations are observing the channel continuously, and if the channel is busy, clear, then they will not send their packet into the channel. And if it is found idle still, after some time being it is found idle, then still it will wait for the particular frame duration. That is called interframe space. This will wait for the particular frame space. Clear? You can see there is a frame space. Clear? It means the channel is idle, but it is still wait for a particular frame time. And if it is found idle for a one time slot, then it will send the data with the contention window. Contention window is what? It means suppose uh, there is a successful frame, there is a frame available to each slot, and then it will send the contention window where the collision may happen. Clear? So it will just record that collision at that time. This is called interframe space. Another one is contention window, and the third one is acknowledgement. Clear? In this acknowledgement scheme, exactly we can avoid the collision just by getting acknowledgement from the receiver side. Means suppose the sender sends the packet successfully in the idle condition, and the receiver acknowledges that the packet is received successfully. Clear? So in this fashion we can avoid the collision. Means at both the side the packet, whatever packet is transmitted, that is received. Clear? So in this fashion we can avoid the collision. Now this is the flow diagram of the CSMA CA scheme. You can see, as we have discussed about for CSMA CD, and this is the CSMA CA scheme. Now okay, so now we will discuss the channelization process. Okay, in this channelization process, channelization is exactly the multiple access method in which the available bandwidth of a link is shared in each time. Yeah? Means जो भी bandwidth available होगी वो हर एक टाइम ड्यूरेशन में शेयर्ड होगी with